Welcome to this session. This session will continue with our discussion of complex matrices. So let's start by defining what we mean by transpose of a conjugate of a matrix. Transpose of conjugate of a matrix. So the transpose of a complex transpose of a conjugate matrix transpose of conjugate of a matrix A. So there's no R. So the transpose of conjugate of a matrix A is denoted by A power theta or A star. So that's to say, if this A transpose, this is the conjugate of A, if you transpose it, then you get what we call A power theta, or is the same thing as writing A star. I remember the same, we can write the transpose of A conjugate is the same as writing by A then this prime or then this power T. So these have the same implication. Now, the next statement, the ij element of the matrix A star, A theta, A raised power theta is equals to the j I element of the conjugate of A matrix. So that's to say, which is the same thing as saying complex conjugate complex of I j element of A. So for example, given A equals to 2 plus 3i, 1 minus 2i, 2 plus 4i, 3 minus 4i, 4 minus 3i plus 3i, and then 2 minus 6i, 5, 5 plus 6i, and 3. This is a matrix A. Find A power theta. Find A power theta. So remember we said A power theta or A star is the matrix obtained by getting the transpose of the conjugate of matrix A. So the first step would be to get the conjugate of matrix A, and then once we have that conjugate matrix, we get its transpose. So solution, first, we get A conjugate, i.e. A conjugate is the matrix. So the conjugate of this element will be 2 minus 3i. This one will be 1 plus 2i. This one will be 2 minus 4i. This one will be 3 plus 4i. This one will be 4 minus 3i. This one will be 2 plus 6i. This one, 5 remains to be 5, is conjugate. This will be 5 minus 6i. 3 remains to be 3. So that is the conjugate of matrix A. Now, once we have the conjugate of matrix A, then we get its transpose. So the transpose of this matrix means rows becomes columns and columns becomes rows. So we'll have 2 minus 3i, 1 plus 2i, 2 minus 4i, and then 3 plus 4i, 4 minus 3i, 2 plus 6i, and then 5 minus 6i, and then this is 3. Since A power theta, now since A power theta is equals to A conjugate transpose, then this implies that A power theta for this problem is the matrix 2 minus 3i, 3 plus 4i, 5, 1 plus 2i, 4 minus 3i, 5 minus 6i, 2 minus 4i, 2 plus 6i, and then 3. So that is the A raised power theta matrix for the problem given. And then example 2, given A is 1 plus I, 3 minus 5i, 2i, and 5. Find Roman 1 conjugate of A, Roman 2 transpose of conjugate of A, Roman 3, A power theta, and Roman 4, A power theta, raised power theta. So solution, part A conjugate will be given by this conjugate of this element is 1 minus I. This will be 3 plus 5i. This will be minus 2i. This remains to be 5. So that's the first part. Transpose of A conjugate is the same as transposing this matrix. We have 1 minus I, 3 plus 5i, minus 2i, and then 5. So that is the transpose of that given matrix. Now, A power theta is the same as conjugate of A transpose. So we'll have 1 minus I minus 2I, 3 plus 5I, and then 5. So that's what we have. And then part 4, they want us to evaluate A power theta. So this is the same thing as saying we evaluate this. The answer for A power theta is 1 minus I minus 2I, 3 plus 5I, and then 5. So we evaluate this quantity. So which requires us to find the conjugate of this matrix and then find its transpose. So that will be the same as conjugate of this is 1 plus I, and then 2I, 3 minus 5I, 5, and then we get the transpose of that matrix. And that should give us 1 plus I, 2I, 3 minus 5I, and then 5. So that's what that part gives us. So in the next session, we'll define what we call a Hermitian matrix and give some examples. Thank you.